Ladies and gentlemen, please welcome Arlene Ducao and Rachel Mersky.
Hi everyone, I'm Arlene Ducao, co-founder of the DuKode Studio in Brooklyn.
And I'm Rachel Mersky, and I'm the associate designer at DuKode Studio.
Yes, great. It's so great to be giving this presentation on the heels of Dave's presentation, in that the Lower East Side Girls Club is a great inspiration to us, and you might see the game that we're working on there someday soon, so we'll see how it goes. There's a clicker. Oh, great. Okay. Great. So the working title of our game is Encephalodome. If you have, if any evocative alternative titles come to you, please feel free to find us, and you'll be hearing us talk a lot about questions that we're asking, questions that we haven't answered in the course of developing this game. We're still in the very early stages of bringing together sort of three central considerations, which we're illustrating here. One is the immersive space of a dome projection environment. Two is the content of the game, which is our changing oceans, particularly how carbon emissions are affecting sea organisms and how those organisms are being changed by the acidification due to those carbon emissions. And B, you can see a little sliver of this headset I'm wearing, which is an EEG controlled headset. It's a single electrode, very simple controller, low resolution electroencephalography device, which is going to be one of the primary controllers for this game.
So the setting of this game is in our ocean, which in response to carbon emissions is becoming increasingly acidic. As CO2 is being pumped into the water, it binds with the water and it lowers the pH levels of our ocean, which increases acidity, and it blocks the molecules that many shell-forming creatures use to build their shells. So it makes it much more difficult for them to grow and flourish.
And we should mention also that this still is from a documentary that I worked on several years ago as part of the Science Bulletins program at the Natural History Museum, which is another one of our great inspirations for this whole project.
So the gameplay seeks to create an immersive collaboration between players to flourish as sea creatures within this changing ecosystem. The players will represent different sort of prototypical members of the oceanic ecosystem, ranging from those that are formed almost completely from carbonate shells like coral and plankton, and those with those shell creatures that have harder, more resilient shells like lobsters and crabs, and those invertebrates that have almost no hard parts, like jellyfish, which are almost unaffected by the increase in acidity. The game will be divided into levels, representing eras in our history, and the environment of the game will be affected by the pH level of the ocean during those different eras. And so the gameplay will become increasingly more difficult as the pH decreases and the ocean's more acidic, and it's more difficult for these creatures to flourish. And while it's a collaborative game, our aim is to encourage players to collaborate to balance this ecosystem. There's also an element of competition. We want people to strive to flourish most efficiently out of them and their ecosystem mates. So at the end of each level, there will be sort of a winner, like in Rock Band or something.
Exactly.
Your aim is to do the best as a team.
Right.
But you also want to do the best as an individual.
Exactly, exactly. And in determining the overall sort of structure of the game, we decided that we would start at the time of the Industrial Revolution, in that this is an era in which carbon emissions started to come into play on a large scale, and a global scale, that kind of thing. So we're looking, each level represents a milestone, a 50-year milestone from 1750 all the way to the near future. And the interesting thing about sort of each of these players, the roles of each player, there's a similarity between these players and sort of RPGs in that, there are strengths and weaknesses for each player. And then also, not all of the players are dynamic in that some of the players that have simpler or more fragile hard parts may sort of have a harder time surviving in a more acidified ocean, but we've been finding that creatures with more resilient hard parts actually grow bigger in a more acidified ocean. So this will be an interesting sort of educational point to make in this game.
And the setting for this game will take place within the dome atmosphere, the dome environment, which has been typically used in planetariums, exploring space, which we found seemed pretty similar to the environment underwater. You move in similar ways. You're not limited by just X, Y axes. You can also go up and down. And we find that this kind of space encourages almost a theatrical type of interaction between people. People can move around and interact with each other and interact with an audience as well as move within a space. And so,
sure, yeah. So another aspect of the dome projection space that we think is really interesting is, as opposed to a flat screen where you see basically everything on the screen, when you're dealing with a spherical surface, you see local aspects of the screen. Like, for instance, you may see, if you're close to this coral reef, you may see that reef very clearly, but you may not see the more open water on the other side of the screen. So individuals in the space interact with greater proximity to more localized visual images than when you have a flat screen. So this is something that we think supports social gaming really well, and something that we want to leverage in setting up this game. So those are some of the overall considerations of this game, and now we're going to talk about the experiments that we've been conducting here in Brooklyn and also at the MIT Media Lab. This is a very simple game with an earlier version of this headset that is experimenting with notions of mind-based input, mental input, brain-computer interface, and gestural movement input, the Microsoft Kinect, which we have right here. And there have been recent developments on both of these fronts. Some of the processing, the computer vision with the Kinect and the EEG-based processing are about the same age in terms of development time in years. And so we're experimenting with notions of taking the very simple data out of here, simple but very, highly reflective, in that there seems to be a lot of interest in the use of EEG in fusion with other kinds of sensors, other kinds of cameras, in the ultimate effect of making a more meaningful gaming or interactive or movement experience, and so that's what we're doing with this. This simple game was basically, there are two, on this long set of screens, there are two sort of embodiments of you. There is a dark shadow, which is an embodiment of your position on this, to this long set of screens, and then there's this sort of white object that is an embodiment of your brain state. And so the more still the white object is, that's reflective of your stress levels, and the more still the object is, the easier it is to sort of push down this line of screens in a sort of meditative walk. And so for all of this, going back to what Rachel was talking about with spatial considerations, it really gets down to iterations, a lot of nitty-gritty in terms of the circuitry, the fabrication. And so there are aspects of do-it-yourself, brain-computer interface, gestural interface, theatrical and architectural considerations that Rachel was referring to. Also, there are ergonomic aspects, because not only are we making the software, we're also making the controllers. So as you can see here in sort of this central lower picture, there's a 3D printed headset that was an earlier iteration in this whole series of experiments. And while we found that it was striking and attractive to our minds, it was not very comfortable at all. So that's something that we're iterating on, aspects of fabrication and sort of making aspects as well. And so going back again to the overall concept of Changing Oceans game, we're considering what are the kind of mappings of the self, the sort of quantified self, the brain activity, the movement activity. What are the most meaningful mappings that we can make from the controller, the input of the user into the controller, the player into the controller, to the larger world, the world of the ocean, the world, or even other kinds of worlds, the worlds of space, the worlds of larger regions, that kind of thing. There are many more stories to tell, and Changing Oceans is just one of them. And so we're sort of thinking about best practices of these kinds of interfaces in an immersive environment like the Dome, and how we could possibly tell all kinds of other stories, like some of these like those in some of these recent projects from our studio. So we have a few minutes left, and we'll see if we can get this demo going in a few minutes. Let's see what we can do here. Thank you so much for listening. And please do, if you run into us afterwards, have any comments, suggestions, send us an email. Come tap us on the shoulder. Let us know what you think. And yeah, let's see. Okay, great. So what we're doing right here is we're going to show you, oh, here we go. Yeah. So we just have like a very small resolution. Let's see if we can move it down. Oops. We just have a very small resolution, sort of simple. Let's see if we can bring me, yeah, okay, you see me? Oh, great, okay. So Rachel, if you click on the screen, Rachel's basically adding creatures that will come and sort of feed off me, and as the player, I'm the kind of embodiment of a coral reef. And so each of the players will have different headsets that sort of embody or represent the kind of the sea organism that they are role-playing. And so this is a very early experiment, basically, of rigging up like flocking animals that come swim up to a coral reef. So yeah, you'll see that they tend to be attracted to me and the corner. So yeah, very early stage. And I think that's about all. Okay, great.